Hello, everybody. I am Salim Al-Ashhab, a Jordanian mathematician. Uh, Recently, I am in Saudi Arabia at Al-Hafr University. Today, I will talk about my paper about difference equations. Uh, it's a mathematical topic which has some applications in real life. Like psychology, engineering, ecology. We see, for example, the difference system the one, and we see that we have four initial values. We considered this system earlier in other papers, and we are going to develop the theory and generalize such systems of difference equations. We will use computer software, especially Mathematica, in order to obtain some relations concerning the finite summations. We see, for example, this relation. It's easy to verify by using a computer. Then we will try to expand this relation where we denote with the symbol T pairs of expressions, including the number J, and make some summations over J from 1 to m minus 4 for such expressions, and we call such summations PZSN, and we were able to express the value of such summations in terms of products, as we see in these formulas here. We have a special case where we replace the denominator here with the number 1 here in this fraction, and we call it the function QZSN. Of course, this function is easy to calculate. It will also be some product, and it will be calculated using factorials as indicated here. We first start with a one-dimensional sequence. We call yn plus 1 depending on yn, and this fractional equation. PQ are parameters, of course, in addition to R, and the initial condition is just C. Now, if R is 0, we obtain a very trivial case where the sequence is a two-cyclic sequence. Of course, in this case, and a convergent sequence. If R is different than 0, and we have this condition satisfies, then yn converges. We will see at the end what is the limit. Now we start computing y1 using y0 and y2 and so on, and we obtain this form for the sequence yn, and we start making some calculations in order to obtain a simpler formula. We use at this stage this we use mathematics in order to calculate this summation, finite summation, and obtain an expression for that, and then continue in very long calculations, reaching this form of the solution. Of course, using some quantities like z and u, where z and u are written here above. Based on this knowledge, we are now going to calculate the limit of y2 k plus 1 or y2 k plus 2. We distinguish between odd and even indices, but at the end, both of them will yield the same limit which is written here, 2rp over absolute value of r times absolute value of r plus e. And we see that both limits are equal for all PQRC, and they are fixed when PQR are fixed. So they are the limit is independent of C. We demonstrated many examples. So in case PQ is 2 and Y naught is 1 and R is minus 1, we see that the sequence after 24 steps reaches this value, which is very close to the limit, which we can calculate from the formula above, and it is about minus 0.78. Now, our first system will be modification of the one-dimensional equation where the PQ are replaced by xn minus 1, which is a sequence which is given by this function g in the form b over g and r. And we take this formula for the g and r in case r different than 1 and in case r1 is 1. And this formula specifically is generated if we let xn plus 1 be a difference equation in this form. So in this case, we encountered some summations, including some products, the p's, which are products of the GL, and we used our formulas at the beginning in order to reach this form for the solution here, y2k. It includes the function w, which we can't be written in a closed form. But anyway, in case b, ab are positive and ac greater than or minus 1, then yn converges to 0. And this can be proven by the squeezing theory. Now, we also consider the case r greater than 1. In this case, also we proved that the limit of the sequence will be 0. The case r minus 1 was considered. In this case, the gn is this simple function where it's just oscillating between two values. And in this case, we encounter this product as 1 over b minus s minus b minus 1 power s. And in this case, this expression p bar ZECSN includes this term q. We didn't find a very simple formula for the solution. Anyway, we reached that the solution must have this form where D and Fk are determined here in this paper. And we noticed that in the numerical examples that the limit will be not one value, rather it will be two values. So the sequence will reach two values to reach a limit cycle. And we didn't prove that very rigorously. We just make this expectation that in this case, for example, example 3, that we have these two limits, and this is due to the fact that the summations will be in the numerator and denominator almost the same after certain step about 10 power 29, and then we can see that there must be a limit. Of course, here this expression will be about 10 to the power 29, and this is almost the same. Then we move to the second two-dimensional system. We use now 1 over Gn for Xn, but for Yn plus 1, we have Yn also in the numerator right now, and we fix R to be 1. And in this case, we make simple calculations at the beginning in order to see how the form of Yn will be, and we reach that Yn will be in this form. C over Pn, where Pn is given by this recurrence relation. And we focus now our calculation on this form of Pn. We see at the first line that the Pn will reach at the end this expression using this summation. And this summation will be calculated also using Mathematica, and it includes the gamma function, the hypergeometric function f1 above it too. Then we considered specifically this function gl r power l over a r positive, and in this case we were able to calculate the form of the summation. It was easier, and we obtained in this case some information about the numerator of Yn, and the limit of Yn will be 0 since the limit of the numerator will be infinity. We considered here a numerical example where we set R to be 1/2, not 1. In this case, we will encounter a different situation. In this case, the sequence starts increasing and reaches a value about 1, and we proved that this fact that if a is greater than 1 and r between 0 and 1, that the limit of Yn must be in this case 1. Of course, using L'Hopital rule and some calculations with these summations, and you can follow all these calculations in the paper. So the question is now open: what will happen if R is greater than 1, or it is -1, for example, as previously considered in that system? But at the end, I wish to thank you for giving me this chance to talk to you about this subject, and we see here at the end that I have so many students, master thesis students, have finished their study on this topic, and hopefully I will also supervise other students in the future. Thanks a lot for listening.